Hello and welcome to Rationals 1.2, Multiplying and Dividing Rational Expressions. Okay, today we're going to start a brand new topic called rational functions. So, if you're wondering, what happened to Rationals 1.1? Well, because we had to kind of trim and cut out what we don't think we're going to be able to do this year, we decided to cut out the introductory lesson. I mean, there's still going to be some introductory things that I'm going to do in this lesson, but I'm not going to go in and teach you guys basically from scratch, and introduce what rational functions are. So, are we missing out a lot in 1.1? It would be good if we had it, but it's not going to be a deal breaker. Okay. So, to start off today's lesson, I'm going to bring things back to probably like maybe 6th grade, 5th grade math, where you had to do multiplication and division of fractions. Because if you guys remember this skill, it'll help you a lot as we move forward into the more difficult ways of doing multiplying and dividing fractions that involve letters. And eventually it's going to involve factoring as well. So it's going to gradually, as I go from one slide to the next, it's going to gradually get a little bit more difficult. But if you really break it down and look at these problems in the basic sense, you're going to realize, yeah, whatever I'm doing, it's going to be traced back to what I'm going to do on this very first slide, which is going to be basically multiplying and dividing fractions, and all the rules that I bring into there or remind you about are going to be used as well in the later on slides that are going to be a little bit harder. Okay, so let's look at problem 1a, and we have 14 over 9 times 15 over 28. Okay, so we're basically going to multiply these fractions together. Okay, so I'm going to show you guys some tricks to make this multiplication a little easier, so you don't really have to actually go, what is 14 times 15 and what is 9 times 28? I'm going to show you guys some things where you can simplify the numbers before you multiply it, and that's going to make it a little bit easier to get your final answer. Okay, so our first problem, let's rewrite 14 and 15, 9 and 28 into a whole bunch of smaller numbers. So you're kind of almost going to be like factor treeing in your head. So 14 I'm going to write as 2 over 7. I'm sorry, 2 times 7 rather. And the 15 you're going to write as 3 times 5. And notice how I'm actually sticking everybody together, right? So they were two individual fractions before when the problem first started. But now I'm going to just make everybody into one giant fraction, one big happy family basically. So 9 is going to be 3 times 3. And 28 is going to be 2 times 2 times 7. Okay, so if you guys really truly did listen to me and you guys actually didn't use the calculator from the beginning of the year, doing this factor tree of all 4 of these numbers in your head is going to actually be a little bit on the easier side. Okay, but if you guys actually still use the calculator every so often, then maybe you cannot do these things in your head. Yeah, and hopefully you realize that, yeah, I think the advice that I gave is kind of important, because I know what kind of skills you need later on in the year, and I kind of almost force you to use or not use your calculator, so that when it comes to this lesson, then your brain is strong, it's in shape. Okay, so we broke everybody up into smaller numbers, and here's the rule that you kind of want to follow for this next step. Okay, you're going to simplify the fraction, which basically means if you see a number on both top and bottom, you're allowed to cross them out. Okay, so let's see, what numbers do I see both on top and bottom? Because whatever I see on top and bottom, I can cross them out. So let's do that. And I'll use a red pen so that you guys can track it along easier. So I see a 2 on the top, I see a 2 on the bottom, so I cross that out. I see a 7 on the top, I see a 7 on the bottom, so I cross that out. I see a 3 on the top, I see a 3 on the bottom, and I cross it out. Okay, and I see a 5 on the top, but do I see a 5 on the bottom? Unfortunately, no. So there's nothing else I can cross out. So everything is just going to get put back together again. So 5 on top, and the 2 and the 3 on the bottom make 6. And there's your final answer. Okay? All right, so next problem. Division. So hopefully you remember from your elementary school days, or maybe middle school, whenever you most recently learned this, and you're going to say to yourself, when I divide fractions, I need to change it into multiplication by the reciprocal. Okay, and I know some of your other teachers in the previous classes, they might have had catchy phrases that remind you what to do. Okay, I don't remember what those catchy phrases are. All I remember is when I was back in school back then, when I changed it into multiplication, I flipped the second fraction, right? I made whatever's on the bottom go to the top, and whatever's on the top go to the bottom. Okay, so I'm basically rewriting this problem from division into multiplication. And the reason why I want to do that is because then I can follow the exact same steps I did in problem A. Just make one giant fraction and break apart the 12 into smaller numbers, break apart 77 into smaller numbers, break apart 35 and 10 into smaller numbers. So let's do this. So 12 is known as 2, 2, and 3. 77 is known as 7 times 11. 35 is known as 5 times 7. And 10 is known as 2 times 5. Okay, and I'm going to look for things that match. So let's change my color so I can see things a little more clearly. So 2 on top and bottom. I see a 7 on top and bottom. And that's all I see on top and bottom, right? Top and bottom doesn't have a 2. Top and bottom doesn't have a 3. Top and bottom doesn't have an 11. Okay, so when I get my final answer, it's going to be 2 times 3 times 11, which is 66. And because these numbers are smaller, they're a little more easy to manage. Imagine if you had to go 12 times 77, 35 times 10, and then simplify the fraction when the numbers are that big. Yeah, you can do it, but I don't think you're going to enjoy that journey. Okay, so it's much easier this way. Okay, so the bottom is going to become 25. And then you're done. Okay, and you don't have to simplify this fraction because as long as you guys simplified everything originally in the fraction that had every piece that was broken into smaller numbers, as long as that's been done correctly, then your 66 over 25 should be simplest form. Okay, and you can leave your answer in proper fraction. You don't have to make a mixed number. This is perfectly fine. Okay. Okay, this slide, I put it here because I want to remind you, that when we start having letters in the fractions, we have to take into account what is called a domain restriction. And domain restriction is basically going to be a number that we are not allowed to plug in for x. Okay, and the reason why we're not going to be allowed to plug in this particular number in this case, so let's see, we have a x plus 2 on the bottom. So what the domain restriction says basically is we are not allowed to have x equal negative 2, because if x equals negative 2, it's going to put a negative 2 in place of the x, and negative 2 plus 2 is 0, and we are never allowed to have a 0 on the bottom of the fraction. Because if we have a 0 on the bottom of the fraction, that's creating a fraction that we have no idea how to simplify, right? We cannot divide by 0. That answer has not been figured out in math yet. Okay? Or maybe it has, but I just don't know about it. But I'm pretty sure you can't divide by 0. All right? So that's why I put that slide there, because we're going to start having x's in letters and a's and b's on the bottom, which means we're going to have to deal with restrictions. Okay? So when we do restrictions, they're going to involve letters that have been on the bottom or are currently still on the bottom. Okay, so notice how I did past tense. Yeah, for domain restrictions involve letters that have been on the bottom before or are currently on the bottom. Okay, and that's not gonna make any sense as far as why I'm using a past tense, but eventually when I get to problem B, you're gonna realize, okay, that's why you said past tense and present tense. Okay, so currently we have x's and y's on the bottom of our current problem, so we need to make restrictions right away. Okay, whenever you do restrictions, you probably want to do it as you see letters appearing on the bottom. So if you see a letter on the bottom, figure out a restriction. And like I said, the number you want to avoid on the bottom is zeros. Okay, so I see x and y on the bottom, so I need to address my restrictions for x and y, and I need to figure out, is there any number that's going to cause either of the fractions to have a 0 or turn into a 0 on the bottom. So I got 21 times y times y times y. Okay, so when I do 21 times y times y times y, is there a number that if I put it in place of y, and then I go 21 times that number times that number times that number, right? Is there a number that exists for y that will turn 21 into a 0 when I multiply? And you're thinking, how do I turn 21 into a 0 when I multiply? And you think, and you say, I think I got it. If I do 21 times 0, the entire bottom becomes 0, which makes a 0 on the bottom of the fraction, which makes it illegal. So I think I want to avoid putting a 0 in place of the y, because if I do that, my fraction is going to become a 0 on the bottom, and that's game over. Okay, so now let's look at the other one, the x. We got 16 times x times x times x. So what number should I avoid for him? And the number I use for y is going to be the exact same number I use for x, because if I go 16 times 0 times 0 times 0, that's going to become an answer of 0. So I'm going to have a 0 on the bottom of the other fraction. So I want to avoid that. Okay? So let's actually stay on this this thought process of figuring out domain restriction. So I'm going to go back and solve letter A later, but I want to do domain restriction of B right now. Okay, so let's figure out what my letters to avoid in letter B are. So I got what letters are on the bottom of the fractions? I got A and B on the bottom of the fractions. So let's figure out what number I want to avoid for A. And it's basically, what do we got? We got 3 times A times A times B. Yeah, so what number that if I put it in place of A will cause the entire bottom of that first fraction, right? The first fraction, 3 times A times A times B. What number is going to cause that first fraction's bottom denominator to become a 0? And hopefully you're saying, I think a 0 will cause that entire bottom to disappear. Yeah. And same goes for the B in that exact same fraction. If I put a 0 in place of the B, it's also going to make the bottom become a 0. So I better avoid B becoming 0 as well. Okay. And you can go and figure out what number is going to cause the second fraction to have a 0 on the bottom, but you don't really have to, because we already know that A and B are going to make a 0 for the first fraction, so they're probably going to do the same thing for the second fraction, so we can avoid that. Okay. All right, so now we have to look at what problem B becomes, because problem B is a division problem. So watch what happens when I turn problem B into a multiplication problem. We're going to get 10xy squared over 3a squared b. And then we're going to turn it into multiplication. So we're going to do the reciprocal of the second fraction. So 6a squared b squared over 5xy. Okay, so now we look at the bottom of that second fraction. We got brand new letters on the bottom, right? Did the x and y appear on the bottom originally? No, but now they do. So now we have a brand new set of letters that we better say to ourselves, we better figure out domain restriction for them also, because they are currently on the bottom. They didn't used to be there, but now they are. So that's why I said past and present tense, right? The A and the B on the original problem used to be on the bottom of the second fraction, but when I did reciprocal, they switched places. So now the x and the y are on the bottom. You know that, and that's why I said past and present tense of anything, any letter that's on the bottom. So I think you kind of understand what's going to make the x and the y a 0 on the bottom. So we're going to avoid x and y being 0 also. Because if x and y are 0 also, that second fraction becomes a 0. Yeah, game over. Okay? All right, so we're done with domain restrictions, so we can go back to our regular solving or simplifying of these problems. So just like I did in the previous problem, yeah, I'm gonna combine both fractions together into one gigantic fraction, and I'm gonna break apart all the numbers into little pieces so I can cross them out. So 8 I'm gonna rewrite as 2 times 2 times 2, and then x, I can't break that up anymore because that's just one single letter. Then 7, then y times y. Okay, then the bottom I go 21 is going to be 3 times 7. And then I got y to the third power, so y times y times y. And then 16, I'm going to break it up into 2 times 2 times 2 times 2, right? 4 2's. And then x times x times x. Okay, so let's start crossing things out that match. Okay, so I got a 2 on the top. Oops, oops, oops. Why did I erase? Oh, I put it on eraser. I thought I put it on red pen. Maybe I didn't. Okay, so let's cross out things that match. So cross out a 2, cross out a 2, cross out another 2, cross out another 2, cross out one more, cross out one more. So you see what I'm doing? I'm just crossing out things that match. And if I see it on top and bottom, I cross one out on the top, cross one out on the bottom. So, and I think that's it. I don't see a 7. I actually do see a 7 on the top and the bottom. I can cross that out also. So wow, everything disappeared on the top. So when everything disappears on the top, don't put a 0 on the top. Okay, when everything gets canceled out on the top, put a 1. Same thing if everything disappears on the bottom. If everything disappears on the bottom, put a 1. Don't put a 0, please. Okay, so it's going to be 1 up top, then it's going to be 6, and this is where it's going to be really easy to lose track of stuff. That's why I put it in red, because then you can kind of almost see what's still left standing. So 2 and 3 are still left. 2 x's are left, so I'm going to write that as x squared, and then a single y. And there you go. Okay. All right, so let's look at our next problem. So big line, because I'm going to make one ginormous fraction, and I think I'm going to run out of space, so I'm just going to page extend already. Okay, so 10 I'm going to write as 2 and 5, and then x, y, y. And then 6 is going to be 2 and 3, and then A, and B, and B. Okay, then the bottom I'm going to do 3 times A, times A, times B, and then times 5, times X, times Y. Okay, so that was actually not that fun, because the bottom didn't really have anything to cross, to rewrite. Okay, so let's cross out things that match. So do I see a 2 on the top and the bottom? So I'm just going to go left to right, yeah? I see a 5, I see an X, I see a Y. No, I don't see another Y. Do I see a 2? Nope. Do I see a 3? Yep, I see a 3. I see an A. I see another A. I see a B. And do I see another B? Nope. So wow, look, my entire bottom canceled out. So please, 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 I hope you heard me when I did the previous problem. When everything cancels out, do not put a 0, put a 1 in that place. So there's a 1 on the bottom. And what's on the top? So I got 2 times y times 2 times b. So that's going to be 4, right? Because 2 times 2 is 4. 4by over 1, which you can just call 4by. And there's your final answer. Okay? All right, next problem. Okay, like I said, as I push from one slide to the next, they're gradually going to get more and more difficult. Okay, so now you're going to see this, you're going to be like, whoa, what is going on, right? How do I break up these things? Well, to break up these things, you're going to have to use what is called factoring. Yeah, and you're probably going to say, oh man, this is not looking very pretty. Okay, so hopefully you guys know your factoring. You guys still remember your factoring skills, because I'm just gonna plow right through it. So top of the first fraction, you got x squared plus 2x minus 8. So when I factor it, I'm going to figure out what two numbers make negative 8 when I multiply and positive 2 when I add. Okay, what numbers make negative 2 when I multiply and positive 2 when I add. So when you break apart that first fraction, so watch what I'm doing. I'm just going to make one gigantic fraction like I did the previous 2 slides. And I'm going to write that first guy on the top left, x plus 4 and x minus 2. Okay, so if you know how to factor, this isn't going to be not that bad. But if you forgot how to factor, then you are in trouble. Okay, so top of the second fraction, I'm going to do GCF, because I noticed they both have a 3. So I'm going to take a 3 away from both of them. And when I take away a 3 from both of them, it's going to be left with x plus 1. Right? So I'm looking at the top right fraction. So 3x plus 3, they both have a 3, so I take it away from them. Or in essence, I divide by 3. Okay? So 3x divided by 3 is x, and 3 divided by 3 is 1. So that's how I get the contents of the inside of the parentheses. That's GCF. Okay? And if you totally forget how to factor, you just got to go back and watch the video called Quadratics 2.2, I believe. 2.2 or 3.2. Maybe it's 3.2. Yeah, you got to watch Quadratics 3.2, the video. And that's from the second quarter, I believe. Or it could be the first. I forget already. But yeah, just go back on the channel, yeah, and look for a video called Quadratics 3.2, and you'll see it. It'll refresh your memory as far as how to factor. Okay. All right. So let's look at the bottom, and we're going to figure out what two numbers make 3 when I multiply and 4 when I add. And that's going to be x plus 3 and x plus 1. Right? Because 3 times 1 is 3. 3 plus 1 is 4. So that's the numbers that work for him. And the bottom of the last fraction, the one on the right, x minus 2, it can't be factored. It's already good to go. So I just write x minus 2. Okay. So notice how we broke everybody up into smaller pieces, just like we did in the previous 2 slides. And then I'm going to get my red pen out, and I'm going to cross out things that I see on top and bottom. So when you cross things out, you got to see the exact same thing on top and bottom. Okay, so you don't do this, because I got a lot of kids every year they do this. They go, oh look, I see an X on the top and the bottom, so I cross out the X. It's just like that. So they do this. Hey, how come it's not? Why isn't it crossing it out in red? There you go. I have kids that do that because they literally follow what I told them on the previous slides. If you see a letter or number on the top and bottom, cross them out. So they say, I see an X, so I cross it out. No, that's not X. That's X plus 4. Okay, so unless you see an X plus 4 on the top and the bottom, you cannot just pick and choose parts of what's in the parentheses. So here's what you got to cross out. X minus 2, I see that on top and bottom. X plus 1, I see that on top and bottom. So I can cross those out. Okay. All right. Oh, whoa. Okay, I went a little too fast. All right, I forgot to do my domain restriction. Okay, you want to try to do domain restriction before you cross things out, because once you cross them out, you're going to think that they are no longer part of your problem. And if you don't think they're part of your problem, you're not going to consider them when you do domain restriction. So let's go back. Let's look at all my parentheses, x plus 3, x plus 1, x minus 2, all the bottom ones. And ask yourself this question. If I turn any of these parentheses into a 0, right? If I turn this first parentheses into a 0, it's going to be basically 0 times parentheses times parentheses. And if you guys know your math, anything times 0 makes 0. And it doesn't matter how ugly the number is. If you're multiplying by 0, it's going to become a 0 as an answer. So as long as any one of my parentheses, my 3 parentheses on the bottom, as long as any of them become a 0, the entire bottom turns to 0. So that's why in this particular problem, I got 3 numbers that represent domain restrictions. Okay, so let's ask ourselves this question. What number turns x plus 3 into a 0? And hopefully you say negative 3. Then you ask yourself, what number turns x plus 1 into a 0? And hopefully you say negative 1. And last parentheses, what number turns x minus 2 into a 0? And hopefully you say 2 does that. Okay? And those are your 3 numbers that we need to avoid at all costs, because if we don't avoid them, we're going to get zeros on the bottom, and that's going to spell disaster for us in this problem. Okay? All right, so we crossed out the things that match, so let's see what's left standing. So we got a 3 up top, we got an x plus 4 up top, and on the bottom we got x plus 3. Okay, and we can just leave our answer like that. Please, please, please do not cross out the 3 on the top and the 3 on the bottom. Okay, do not do that. This is not a 3 on the bottom. This is an x plus 3 on the bottom. Yeah, and you got a 3 all by itself on the top. So they don't match. I know 3 and 3 are the same number, yes, but this is not a 3 on the bottom. This is an x plus 3 on the bottom. So unless I see an x plus 3 on the top, I'm not allowed to cross them out. Okay, so this is going to be your final answer for problem A. All right, so let's look at problem B. And ooh, this is multiplication again, so not too bad. I'm going to make my one big line. And let's factor everything into little pieces. K minus 3, that can't be broken up any smaller than it already is. K squared minus 1. Okay, so what two numbers make negative 1 when you multiply? And 0, because there's nothing in the middle, so that's going to be a 0 in the middle, and 0 when you add. And that's going to hopefully come to a conclusion of x plus 1, or k plus 1, and k minus 1. All right. Then the bottom of each fraction, k plus 1 stays the same, nothing to factor there. And the right side, what numbers make 3 when I multiply and negative 4 when I add? Hopefully you say negative 3 and negative 1. Okay, and I know this factoring is going to get confusing. You're going to be like, you are going way too fast. All right, but you just got to rewatch that quad 3.2 lesson back from like the first semester, because that's going to reteach you guys how to factor if you guys have forgotten. All right, so cross out things that match. That cancels. That cancels, and ooh, I'm doing it again. Yeah, I know. I'm not being a very good example. I'm sorry. You wanna make sure you do your domain restrictions, because once you cross them out, you're not gonna be able to see them anymore, and you're gonna just put one number. So this is what I get a lot of kids doing. They put one number here. They put -1 as their domain restriction because they're thinking, yep, that's all I got left on the bottom. Oh, actually, well, I should have crossed out one more thing, because k+1 is on top and bottom as well. So I actually missed that. Sorry about that. Okay, so I'll go back and deal with that later. But let's just do our domain restriction. So what's going to cancel out my my second parentheses, k-3? A 3 will do that. And then what cancels out k-1? A 1 does that. Okay, and when you put your numbers in your domain restriction, try to put them in numerical order, where you got smallest number on the left, biggest number on the right. Okay, so put them in numerical order. It's not a deal breaker, but a lot of your math teachers are probably going to be kind of picky, and they're going to want you to put it in numerical order. Yeah. So please, please, please remember to put them in numerical order, smallest on the left, biggest on the right, just like a number line does. Okay. Then I'm going to cross out the k+1s because they also match. So everything crossed out. So when everything crosses out, like I told you earlier, don't put a 0. A 1 is in that spot instead. So you got 1/1, which just simply becomes 1. Okay? All right, so moving on. Okay, C and D. Okay, some more factoring, and we're going to bring back a factoring technique that you're going to be like, whoa, I don't like that factoring technique that you just brought back into our life again. So let's do these next problems. You're going to notice that they're both division. Okay, so here's what you want to do. This is going to be kind of humbug. I'm not going to change it into multiplication by the reciprocal yet. Okay, so I'm going to watch what I do. And I'm not going to make one giant fraction either. Okay, so I got a plus 2 over a plus 3 divided by, and I'm going to factor that top, a plus 4, a minus 3, because that makes -12 when I multiply and +1 when I add. And the bottom is going to be a plus 3 and a minus 3. Okay, so right now I got to do restrictions, because in a very short while, the a plus 3 and the a minus 3, they're not going to be on the bottom anymore. Because when I flip the fraction, the a plus 3 and a minus 3 are going to go to the top. So I want to do domain restrictions now, because if I wait till the end, I'm going to forget that a plus 3 and a minus 3 were once on the bottom. So I want to do my restriction now. Okay, so let's see, what's going to make everybody into a 0? Well, a -3 is going to be one of my restricted numbers. So -3 for this first parentheses, -3 for the second one, and +3 for the last parentheses. And you're wondering, why are you spacing out all your numbers like that? Well, like I said, you want to put them in numerical order. So I might have to put numbers in between -3 and 3. I might have to put them on the left, put them on the right. But yeah, I want to put them in numerical order, so I'm spacing them out just like that. And it looks kind of weird. I'll fix it later. But yeah, I just want to keep track of what numbers make 0 in each parentheses. Okay, so now I'm going to do what the division sign says to do, which is flip the fraction. So a plus 2 over a plus 3 times, and then the a plus 3, a minus 3 goes to the top, so they're no longer on the bottom. And that's why I wanted to do domain restrictions already, because they disappeared from the bottom. They are no longer on the bottom. And now I got brand new parentheses on the bottom, which means I want to look at domain restrictions again, because what if I have a brand new parentheses that produces a 0 on the bottom that I didn't have before? So, has a plus 4 ever been on the bottom before? No, it hasn't. So I better add that into the mix. So what's going to make a plus 4 become 0? And this is where you say, I think -4 will do that. So -4, I put it on the far left because it's smaller than -3. And let's see, what's the other parentheses? A minus 3. Okay, that's been on the bottom before, so that's not a brand new number. So let's clean this up. Let's clean up my restrictions, because I left a big space in the middle, but I didn't really need to. So let's make this all a little bit nicer. And there's my 3 numbers for restrictions. Okay. Okay, so what I normally do is I usually make a giant fraction after this. So here's what I do. Watch what I do. It's kind of tricky. It's kind of like, okay, that's kind of sneaky, but it works. Okay, watch what I do. So I have 2 separate fractions with a dot in the middle. Watch what I do. I just make the line longer, and I go and I make sure my line goes through the dot. So now I have 1 giant fraction. Okay, and then I'm gonna cross out things that are on top and bottom. So I don't see an a plus 2 on top and bottom. I see an a plus 3 on top and bottom, so I cross that out. I see an a minus 3 on top and bottom, so I cross that out. And what's left? A plus 2 over a plus 4. Okay, and here's where I get kids making a mistake again on this problem. They see the 2 and the 4, and they go, oh look, 2 and 4, that can become 1 and 2. They think they can cancel out the 2 and the 4 to become 1 and 2. You cannot do that. This is not a 2 and a 4. This is an a plus 2 and an a plus 4. So unless I see an a plus 2 on the bottom, do not touch that a plus 2 on the top. Okay? So this is going to be your final answer for this one. All right. Okay, almost done. Last problem. Okay, so let's factor this out. We got b plus 2 on top. We got b minus 5 on the bottom. And wow, we got to do sum, or what is it called? Sum of cubes, yeah, on the top. And that's going to be the one that I taught you guys, I think, back when it was Polynomials 4.1. Yeah, and it was the recipe story that I told you to break apart b to the 3rd power plus 8. Okay, so I'm not going to use this time in this video to reteach you guys how to do factoring of b to the 3rd plus 8. I'm just going to write what it becomes. Okay, you guys can go and rewatch that video to learn how I did this so quickly. Yeah. So when this b to the 3rd plus 8 gets factored, it's going to become this b plus 2 times b squared minus 2b plus 4. And you're probably wondering, how in the world did you get that? Okay. Yeah, just rewatch Polynomials 4.1's video. Okay, that's all I can tell you, right? Normally I would take the time to show you guys how it is, but I want to keep the focus on the very essence of this problem, which is basically breaking things up into smaller pieces, crossing things out, dealing with your domain restriction, and just focus on that. Okay, if you guys have issues with the factoring, you got to go back and watch videos. Okay, that's the best advice I can give. Okay, so the bottom of this guy is going to become b plus 7 and b minus 5. Yeah, otherwise, this video is going to be like an hour if I had to go back and reteach everything from scratch. All right, so let's do some restrictions. Yeah, let's do some restrictions. So I better avoid 5, because if I put a 5 in that first parentheses on the bottom left-hand fraction, it's going to become a 0. And I better also avoid negative 7. Okay, those are the 2 numbers I better avoid. And you're wondering, why am I doing it already? Well, because the b plus 7 and the b minus 5, they're about to actually not be on the bottom anymore. Okay, all right. So let's flip this fraction. So we got b plus 2 over b minus 5 times, and then we're going to flip the fraction, b plus 7, b minus 5, and that's going to be brand new things on the bottom, so b plus 2 and b squared minus 2b plus 4. Okay, all right. So now we got to check to see if any other new entries to the domain restrictions have appeared. And I think we better add negative 2 to the list. So let's put a negative 2 as well. And you're probably going to think like, whoa, how do we figure out what makes 0 for this other guy? B squared minus 2b plus 4. Okay, so this is going to be where we got to solve for b to see if there's any other values of b that are going to create 0. So let me create a blank page because I'm going to need some space. And this is why I didn't want to take time to reteach you guys how to do sum of cubes. Okay, so b squared minus 2b plus 4. How come I can't get to this add the page? b squared minus 2b plus 4, and we're trying to solve it for 0. So let's do this. Okay. So probably the easiest way is just to go complete the square. So we're going to subtract 4 to get rid of that 4. Then we got b squared minus 2b equals negative 4. Okay. Then we're going to figure out what number should go in place in that blank spot that is now vacant, because positive 4 is not the number. So we're going to grab negative 2, cut it in half, get negative 1, then square negative 1 to get the number that's going to go in that spot right next to negative 2b. So that's going to be a 1. So we're going to put a 1 right there. And make sure you add it to both sides. Okay, so we're going to factor this left side. So b minus 1 squared equals negative 3. Okay. And then we're going to square root both sides. And we're going to get b minus 1 equals plus or minus square root of negative 3. Okay. Then continue this journey. So b minus 1 equals plus or minus. The negative turns into I, and then times 3. So circle things that match. So we get b minus 1 equals plus or minus I root 3. Okay, and I'll explain what's going to happen in a little while as far as what's going to happen with this b value, this answer we're getting. But right now, it looks like we're not going to have to worry about the domain restriction for b squared minus 2b plus 4 because a certain letter has popped into our answer. Okay, and I'll explain that a little later. So add 1 both sides, and we get b equals 1 plus or minus I root 3. Okay, so because that imaginary number has popped into our answer, it's not going to be used as a domain restriction. Okay, for domain restrictions, you're only going to use real numbers. Okay, this imaginary number is not going to be there. So we didn't know it was going to be an imaginary number, so that's why we had to actually try it out. But we realized, yep, it's an imaginary value, so we're not going to add it to the list of domain restriction numbers. So let's just continue on with simplifying this fraction, and we're going to cross out things that are on top and bottom. So cross out the b plus 2's, cross out the b minus 5's, and I think that's all I can cross out. Let me expand my page, so I'm kind of running out of space. So b plus 7 on the top, and b squared minus 2b plus 4 on the bottom. And there's your final answer. Okay, so I know this lesson was kind of rough because we brought back factoring into your life, and yeah, like I've been telling you guys in class, right? The key to succeeding in higher level math is maintaining knowledge, because you never know when we're going to call upon a skill to come back into your life all of a sudden. Okay? Best of luck on this assignment. Yeah, and if you got to rewatch videos, take the time to rewatch, because otherwise, yeah, you're going to get frustrated, you're going to get confused. Okay, so best of luck, and I'll see you in class. Bye-bye.